Hello, everyone, and welcome to today's webinar on managing machine-generated data in the growth or in data life sciences. Excuse me, getting a little stumbled up there. I'm Bob Cohen, and I'll be your moderator for today's conversation. Just a quick housekeeping item before we kick off. You probably noticed that you have joined in listen-only mode, but we would like for you to be a part of the conversation as well. Therefore, you can use the chat function on the bottom of the Zoom control bar. That will allow you to write in questions or just write in comments. We are not using the Q&A icon, so don't be confused by that. Or I'm going to just reverse that. I'm getting off on a rough start. We're using the Q&A icon, not the chat. So you will be using the Q&A icon to write in any questions or comments, and then time allowing, we will address those at the end of the webinar. As for the topic of today's webinar, there have been amazing advancements in technology associated with biomedical research, an area that we often sum up as life sciences. Instruments like electron microscopes, DNA sequencers, spectrometers, just to name a few, are not only giving us tremendous new insights, they're also creating tremendous amounts of machine-generated data. And what we're seeing in the field is that often the technology to manage that data is sometimes more of an afterthought or sometimes not even in the equation. And that's creating real problems for administrators of these systems. So fortunately, there are other industries who have been working with this for multiple decades. And we can learn a lot by looking at their approaches to managing machine-generated data. And to take us deeper into that conversation, we have Spectra CTO Matt Starr. So Matt, I'm going to turn it over to you. Hopefully you don't stumble quite as much as I do, and we'll get this conversation kicked off.
Thanks, Bob. So really when we're talking about this level of data, we can look at a pyramid of data here, and we have Optane, which is a non-volatile near RAM-like storage device, all the way down to tape and Glacier. And these are all these different tiers of where you can be putting this research data. But the important thing to realize is industry studies show that about 80% of that data today is inactive. It's not being used, it's not being worked on, but it's sitting most likely also on the wrong tier. So what we're going to talk about is industries that have these large data set problems, how they've solved them, and how you can apply that to a life science workflow. So here's where the problem comes in is you end up with a system where you have 8x data growth in some cases. You have a machine that's now generating data faster, a sequencer that can now sequence data faster, an electron microscope that can generate data faster. You get 2 times more machines, right? The machine, you never get rid of one, you buy a new one, a higher resolution one, but you still keep the old one, it's still running. And so the data content coming off the machines and the platforms is doubling. And then we look at resolutions on these machines, what they're going to. The resolution doubles, and you end up getting kind of an 8x increase in your data year over year that you could be generating. And what happens there is you have a large focus on the science because the machine's great at look at what all the new discoveries it's doing. But when you look at where you're putting that data, that's the part that's not being re-architected for this new machine coming into play. And so when we look at just an example of what happened to everybody on the call here today is the COVID outbreak. And this is some examples of the data that COVID generated. And this is just a small sampling. This COVID generated a ton of data. But as an example, if you look at, if a test, a COVID test with all the medical records associated with that test required 10 megabytes of data, the number of tests we issued, 450 million tests, that would generate about 4.5 petabytes of data. When a person goes into the hospital, and if you think about COVID being a respiratory disease, there's PET scans, X-rays, possible MRIs. Easily a patient can generate 15 gigabytes of data. That would have generated over half an exabyte of data. And so we have these systems now that are very accurate at scanning and creating data, but we're not architecting systems to store it. There's a system out there today that has scanned, or a consortium out there that has of 172 countries that has created about 7 petabytes of data from each unique coronavirus genome scan that they've done. So from an industry standpoint, let's look at who has data, who's creating data, and who's solving these problems. We talk about media and entertainment, and that's one we're going to focus on a little bit today. They went through this kind of 8x growth rate in the past. Let's go back 20 years ago. 20 years ago, you most likely watched what was called standard definition television. And along came high definition television, and along came digital broadcasting. And then we now have 4K and 8K TVs. If you look at your iPhone, if you look at a GoPro camera, the first GoPro camera shot in SD and barely into a 720p. And now with the GoPro 9, you're doing 4K, 60 hertz, which is 60 frames per second. And that's a camera now you see if you watch any kind of a car show or other action show, you'll see these little GoPro cameras stuffed all over the vehicle, taking film from 4 or 5 different angles. And those cameras are generating 4K resolution, 60 hertz per second or 60 frames per second content. And so when we look at that M&E workflow, we can map it on top of life sciences, and they actually kind of map one right on top of the other. They do a lot of the same things. That GoPro camera is really kind of equivalent to your sensors or to your microscope. They could be equivalent to your genomic sequencer. And so when we look at those, here's a good map of those. We have the camera coming in with raw footage, right? And we're talking about if it's a red weapon camera, which is the David Jackson's, he did The Hobbit and things like that. His preferred, I'm going to move something here real quick. His preferred camera of choice. Today, the red weapon generates at 8K, it generates 7 terabytes of raw content per hour. And so massive amount of data coming in. He doesn't know if he's even going to use it yet. But what he's going to do is he's going to review those clips and decide kind of, yeah, that we're good enough on that shot. Let's go to the next shot, take 17, and we'll go to the next scene. And then he'll go into edit. He'll take, hundreds and hundreds of hours of content and pare it down to possibly a 2-hour epic movie. He'll go into post-production where he'll do color correction and try to line up things that may not be in the rough cuts of those edits, like post-production operation. Then he'll go to play out. And when we look at the science side of data, in other words, forget now entertainment, let's look at science. Well, you have an electron microscope, you have a sequencer. It's pulling in this level 0 data, this raw content coming in. You're going to do a QA step on that data, decide if it's correct or not. Do I have to rerun the job? You're going to go into analysis and check to see what this genome sequence is, or what did we find in this electron microscope scan. You may then go into peer review, and you'll go into publication. So when we look at these two things, they go through these kind of 4, 5, 6, 7 steps of acquiring the data, QAing the data, operating on the data, going into some kind of post flow on the data, and then publicizing the data. And so let's think about if we take media and entertainment and we overlay it on top of this, how do we map those two to see what they look like? So here's media and entertainment workflow. This is a diagram from our website, actually. And on the left there is the primary tier of data. And what's happening is a customer is acquiring data on a camera in the field. I'm going to pretend we're doing a commercial for Audi. I was actually sitting in one where we did a class, and it was for Premiere Pro from Adobe, and they actually had us do an Audi commercial, and they had the clips already done, but they're acquiring all this data in the field, bringing it in, landing it on a primary tier. Then there's this item called an asset manager, and that's really just a very specialized object storage system that understands M&E digital content. It looks at it, it knows the frame rate, it knows the header part of that system, and it understands all about that clip and what it is. So the editor can actually say, I need the clip scene 2, take 17, and it'll pop that clip up out of that digital content system there. The other thing about this workflow is one of the first things they do is when that digital content enters that primary tier, they actually make a copy of that to the archive. And the reason they're doing that is a couplefold. One, that's really immutable data. They want to keep it. That's the original content. They I'm stumbling. They cannot recreate that clip again. So they make almost like a backup copy or the original copy of that system. And then what they do is they operate on it, and they do edits and things like that. And they may be making copy of those intermediate results. And at the end, they go to a publication, and they'll make a copy of that into the archive. So all through this, the data may be in a very active state, going into an inactive state, but every time it goes inactive, it's being moved into the archive.
And Matt, is it also fair to say that as it, as this data is brought in and manipulated, and you talked about for peer review and publications and analysis, that's all creating more data as well that somehow needs to be associated with that original data collection?
Yeah, so intermediate results, there's an interesting statement about intermediate results, which is intermediate results, should you keep them or not? And some people believe, especially in science, if you can recompute, great, recompute. But then you're keeping the algorithm that did the computation, and you're hoping that the system that does do that has no, it shouldn't, but in a digital world it shouldn't, but is it going to generate the exact same result? When you think about genomes, there are analog parts of that workflow that may, under a different circumstance, give slightly different results. So yes, I think you should keep your intermediate results and then package them all up as one program and take them out. Bob, there was an interesting read on NASA. They found some data from 30 years ago. They recomputed the data and they were able to discover planets in the solar system that could maintain life. And that same data set 30 years ago didn't show that.
Right.
And so capturing of data and never throwing it away when it's original content is pretty important.
Great, thanks.
Yeah. So here's an example of a M&E workflow. This is a real live customer. It's the Imperial War Museum in the UK. They have 2 different sites. They have Duxford and London. And what they're doing here is this is actually the Korean conflict. At least the last time I was out there, they were in the process of digitizing all of the radio broadcast, and not like combat radio, but radio broadcast as in news, the film content and pictures. They're digitizing that in the highest resolution they can, and then they're storing it off into an archive. Part of the workflow, though, is to digitize the content, have a librarian or a curator look at that, make sure it's a proper resolution and no scratches in the film. But then they also transcode it, and then they publicize it down to the museum so that if you want to look at, for example, in 1952, they may be able to bring up a library of all the radio messages from 1952 about the Korean War. They also are now using a product from us called StoreCycle, and they're using that to actually archive some other assets in the system and moving that into the same archive. So pretty interesting place where they're growing they have 750,000 digital assets, and they right now are generating about 1.2 petabyte of data in their bulk storage. So it's a big archive, and it's going to continue to grow because the analog content that they have will not last, right? It's nitrate film in some cases, and they have to get the nitrate film. They get one shot at kind of playing that, get it off, get it digitized at a very high resolution, store that high resolution copy away, make 3 copies of it, and then maybe make a YouTube video or a Venmo, fine, but a small resolution clip of it that can be played out over a wide area network. So another one, this is Radio Television Hong Kong. This is kind of a neat one for me. I've been there a couple different times, and I was actually there during in Hong Kong during one episode of the riots that they had there. And the guy that works in their IT department kind of at night during this was actually grabbing a camera and going out and filming some of the riots going on in Hong Kong and bring it back in and adjusting it for the news the next day. But these guys are the oldest broadcaster in Hong Kong. They have 7 radio stations, 3 television stations. They generate about 100 gigs of content every day. And what they're doing is they have a custom piece of software that sits there and watches that main storage system and then grooms it off. Now, the value of getting that data off that primary store is really make the primary store run faster. You save money. That's also a benefit. But when you take a primary store and you fill it up, the file systems actually run slower. So instead of just continuing taking, for example, the Isilon system and adding content and more Isilon and adding content and more Isilon, what these guys are doing is actually grooming it off and keeping that sandbox or that working area the same size. And where the content grows is in the inactive portion, the stuff they're not using anymore. They basically store that away forever. So here's that workflow. And if we look at that, we have all these different parts about production and post-production. We could have edit and play out. But in this case, most of that content, the original content and even the curated content or the post-production finished film may end up in that archive or that tier 2 system. Only when it goes to playout does the playout system reach in, grab it out of the archive, put it on a high-speed disk, and get it ready to broadcast out to all the television stations. If we overlay that on top of life sciences, the workflows look pretty much the same. We have generating a sample, we have library quality control, we could be sequencing and analyzing, and then publishing our science. So that workflow looks very much like M&E, and we can now kind of say, how do we make an M&E workflow work well or close to the same steps for life sciences? And so for StoreCycle, that's one of our products. There's other data movers out there, but StoreCycle is one that we've seen a big uptick in life sciences. And what's happening here is you have your machine-generated data. This is an cryo-EM microscope, a sequencer, some device out there that's generating just tons and tons of data, running 24 hours a day in a lot of cases. That's going to come in and land on a primary storage tier. And then what may happen is you're going to do some work on it. You're going to run it through an HPC system, do a fast Fourier transform on it maybe or something. You're going to go into what we'd call like a post-production system. But if you put StoreCycle in this workflow, what you end up with is being able to take copies of that data out of the primary store, put them on a lower cost tier of storage like tape or even object storage disk, and keep that primary tier of data running fast, efficient, but also keep your footprint down from a disaster recovery standpoint, from a cost standpoint. Very easy to move this data off when it's not being accessed into that lower tier. So some examples of customers that are doing this today. This is IBS. This is the Institute of Basic Science in Korea. They basically specialize in science that takes a long time to do, and for the country of Korea, and it takes a large group of researchers. These guys today are generating about 2 terabytes of data every day off those cryo-EM microscopes there. And what they're doing is they're taking that data and putting it into a Lustre file system and then running an HPC system against it and generating their science. But once that's done and the science is done, they can actually, again, groom that data off the Lustre file system, put it into a tape archive, making 1 or 2 copies, and save a bunch of money. Today, this system is 16 petabytes, and it's going to be growing to 32 petabytes here shortly. This is a U.S. federal site. We normally don't use their name. They are studying disease and disease prevention. And they've been using our product for about 20 years, and they've had a couple new workflows come into that system. So their normal workflow is really kind of backup and archive in their for all their data sets. But a new workflow they have is they're actually archiving SQL data. It's still medical data, but what's happening is they're dumping into SQL databases so they can do operations on that. And then when that data set is done, they take the entire SQL data set, pull it out, dump it to a file, and we pull it off and put it to tape and make multiple copies. Now, in normal cases, this is just sitting on disk for about 30 days so they can still bring it up when they need it. And then once it's done on disk, we make dual copies to tape. And the last one, this is a worldwide health research team. They have a Linux-based cluster. They use BGFS, which is another clustered file system for high performance computing. They have about 400 terabytes of clustered file system. And the issue with that clustered file system is it was running at about 93% full. And if you know anything about file systems, once you cross 80%, you start to dip into max performance and you start to cut it down. When you cross 90%, some clustered file systems can drop performance by more than 50%. And at 93, you're really getting into trouble. And so you want to get that clustered file system freed up. And so what they did is they started with StoreCycle and Eon Browser. Eon Browser is a kind of a side-by-side panel system that you can drag and drop data in and out of a archiver like Black Pearl there. And over 1/4 of this data that they had on the system was inactive. So all of a sudden, they free up 20% of their file system. Then they go back in and look at it again, and they find another 70 terabytes that's inactive that they can pull off. So all of a sudden, within a few days of deploying a solution like this, they've cleaned off 40% or more of their file system, and the performance of that file system is back at 100%. So here's that M&E workflow, and if we lay right on top of it the life sciences workflow, they're identical. And so we talk about, we need to acquire the data off the microscope or the IoT device, be it the cryo-EM microscope, the genomic sequencer. We're going to acquire that data. Once we've acquired that data, we probably want to store that original content, that level 0 content, make a copy of it, make it immutable. You can't regenerate it in some cases. We have a solar program going today with one of a U.S. federal agency, and they can't regenerate the data. It's coming in, and it's precious, and they need to keep it forever, and so they want to store it immediately. They may then build post-production results off of that level 1 or level 2 data sets off that can be recomputed, and they may not have to store multiple copies of that. But the first thing they want to do is get a copy of that stored off. And then what you want to do is you're going through your workflow of genomic sequence or your EM, cryo-EM microscope, and you're going through this workflow and generating science. All of those intermediate results, you could also be storing down in the archive as opposed to keeping them on your file system, on your clustered file system. And the reason, again, to do that is cost and performance. Keep your file system, especially in an HPC world, keep your file system running the job that it's running today and tomorrow, not things from last week, not things from a month ago. So kind of to wrap up, M&E and life sciences have a very common, in my opinion, a very common data set and workflow. You're generating, in most cases, terabytes and terabytes of data per day. The data is very active early and can become very inactive very quickly. And I would say that M&E today has already had proven solutions for using StoreCycle to take this data off those clustered file systems, get it down into an archive, still 100% accessible. Anything on the system can pull it back up, get it ready, put it into a sandbox, get it operational. That's a great tool for doing it. There are some other ones out there that you could certainly look at besides StoreCycle. And the big takeaway here is, stop backing up level 0 data, right? If you have original content that you are no longer touching, don't back it up every week. Take it and archive it, make 2-3 copies of it in the archive. And what you see is all of a sudden even a backup window will shrink. You can use StoreCycle as your archiver. You can keep your high-speed file system working and not running slow. And then the last thing there is make sure that you can, if you do have original content and intermediate steps, that you can recompute if you have to, if you're going to not back those up or not put them in the archive. So the other thing with StoreCycle, in my opinion, is you have this workflow, you have this structured idea of science happening in that you go through known steps, right? Almost like an ERP system, producing a car or producing a robotic tape library. We go through a known number of steps. Those workflows, it's easy to integrate things like StoreCycle and your clustered file systems and know how that data is going to be operated on. But then we get into some of the unstructured or unmanaged data assets that you could start to look at. So once you've solved the structured or managed data problem, let's look at your unmanaged data problem. And that is things like, how about the code that you're writing or your scientists are using? Algorithms, white papers, all of this stuff that may be coming out, but it isn't in the core science workflow. How is it being protected? How is it being archived? How is it not sitting on that high-speed file system inactive? So deploying StoreCycle in these cases, what it gives you is the ability to look at that large clustered file system, then get a view of what's inactive, what's the size of it, when it was last touched or read, modified, whichever way you want to look at it, and then determine by job, say, what if I do the following 3 things? I move every file that's bigger than 10 gigabytes, that's older than 1 month. What does my file system now look like? And that's one of the things StoreCycle can do for you, is give you this mapping of, if I do this job, what's it going to look like? And then click a button, go, the job runs, cleans that file system off, gives you the opportunity to boost the performance of it. And then anytime you need that data back, it's just a quick click, a hyperlink back, and the files are coming back onto your clustered file system. So we have a lot of proven cases out there for customers in media and entertainment, oil and gas, and life sciences using StoreCycle to keep their clustered file system, their high performance file systems freed up of clutter, and at the same time protecting those assets for the life of the asset. And if you want to read more on that, there's a white paper right here at this link that I think Katie or someone may be able to drop into the chat box. So Bob, that's it, and that's how we're kind of solving the problem in life sciences by mapping right on top of these common workflows, which is 4 or 5 steps of data ingest all the way to publication.
Yeah, beautiful overview. And Matt, we had a couple of questions come in as you were presenting. So people did figure out it is the Q&A, not the chat icon. So keep those questions coming in as you have more. And I see another one just popped in. The first one came actually as I was asking about how you keep those collection or data sets collected as a group. And the question was, you mentioned managing data sets created from the original data collection. How do you keep different data sets associated with the original data collection set and keep that association? Did you follow what that question is?
I think I did, yeah. So so a lot of people, that's really workflow dependent. Media and entertainment guys, they use directory structures, to be honest with you. And then their media asset manager, the MAM, or a digital asset manager, the DAM, then they also, just like projects, they create project names. Then they go out and they import those project names, those assets into the project. And so underneath that project are pointers to those assets out on the disk. That system works well for them because the project doesn't include, 50 million assets. It includes 1 million, assets possibly. So it could be audio, it could be closed caption, it could be the video content, it could be all those pieces. But the object storage system, the MAM, is actually the one that's giving them a view. It could be scattered all over the place out in their disk ecosystem, and that asset manager is the one giving them the common view. I will tell you that most of the time, directory structures do work for these kind of workflows. The issue is when you put it away and archive it, that's the step that you want to kind of take and do something a little different, which is maybe put it all in one bucket. Since we're talking about object storage in this case with StoreCycle, I put it in one bucket. So if you have a project, make a bucket called Project A, put all of the original level 0 data in there, and then maybe put all the rest of the intermediate results in there.
Okay, and that's kind of a follow-up question I was going to ask is, if they use something like StoreCycle to move that data, and you said you still have access to it, will you see that same structure when you go to look for it?
Yeah, you certainly do. We're not going to obfuscate it from you. We're not going to make grids out of it or something like that. It's kind of a one-to-one view. And you can use StoreCycle to recover that data, pull it back up, or you can use the browser and actually just kind of poke into the archive behind the scenes, look at that data set that got archived in that bucket, and pull it back out, for lack of a better term, by hand.
Okay.
It's Bob, it's analogous to your taxes. You don't keep your taxes on the dining room table in November. You put them down in the basement, and that's the same kind of thing when we think about these workflows.
Okay, great. Next question says, I saw cloud on your workflow diagram, but you didn't mention it. Can that be used as a target for storage? And is there any difference in how that's managed?
Absolutely. Behind StoreCycle Cloud is available. It's also available behind Black Pearl. How is it managed? It's again, it's not obfuscated. So as you put objects, as StoreCycle is migrating assets off of a clustered file system in the case of IBS Luster, that file name is going to become the object name. So let's just say /directory/file name. That becomes the string that is the object name. When we put that to cloud, behind Black Pearl in a bucket called My Project, it will be, the object name will be /directory/file name. So it's not, again, it's the file is put up there as it was here, to the point where you could actually use a completely separate tool, access that bucket, pull that object down, put it onto a file system, and it would be the file that we archived.
Okay, great. Let's see. Next question. Can StoreCycle replace things like project parking and Marquee? Or maybe
Marquis project parking. It could. I mean, there's some other things that project parking does, but yeah, we do have post-production guys using StoreCycle for pretty much what you're talking about there. Slightly different integration with Avid. If you're talking, if you're running project parking as a standalone entity versus as integrated with Avid or other edit stations. But yes, it could do similar things, which is what project parking is for those that aren't in the media and entertainment world. let's say I'm the post-production guy and I need to take a logo out of this shirt because I didn't license it. I'm going to use a very specialized piece of software that will actually blend the colors of my shirt away frame by frame by frame. And it's an operation called post-production. I could also do color correction, lighting corrections, all these things in what's called post-production. Well, post-production is a job that's usually rented out. I send it off to a specialized company. They do the work. They give me back the assets when they're done. They're getting jobs in and out all the time. And so what project parking does for them is if somebody comes in with a rush job, hey, I need you to fix, we have one more logo you need to hide. I need it tomorrow. They can take the project they're currently working on, park it into a kind of a digital parking lot, bring the real fast job into play, operate on it, and then get it back to the customer. And really what project parking is doing, to the point of what StoreCycle does, is it frees up that high-speed file system because they're doing nonlinear editing on a high-speed file system. So they want peak performance.
Gotcha. Okay, next up, is StoreCycle a file system in and of itself as well, i.e. a full-up HSM and its file system, or is it some technology that can work within industry standard file systems?
Is the latter. So,
yeah, so this is not a parallel file system or
no.
Or what I would consider a forklift upgrade if you implement. Right?
No, you could think of us as we've taken a storage resource manager and a data mover and then plug them together. And so what StoreCycle is going to be able to do, it's going to be able to mount a POSIX file system. It can then scan that POSIX file system, and then you set up jobs on StoreCycle to say, I would like to do on this directory this level of operation, 100 gigabyte files, 30 days old, move them to bucket A. And StoreCycle will start pulling that data. It will migrate it to whatever target behind it you've given it. So it is a software-only solution. Migrate it to whatever target behind you assign. It could be cheaper NAS. It could be Black Pearl, Tape, Cloud, all those other devices. And then what it can do is it can either leave a SIM link behind if it's on NAS, or better yet, an HTML link, which kind of allows you to trigger whether you do a restore or not. And that's important when you're thinking about production file systems. Let's talk about an Isilon system that's running really fast. If you have a researcher that says, hey, I'm going to bring back a petabyte of data, and he crushes your file system by restoring a petabyte of data from the archive and it stops your production, that's a problem. So we actually have the ability to allow users to do it, or actually only send it to admins and only have admins do restorations like that from StoreCycle.
Gotcha. And last question so far, unless anyone wants to write in more, is StoreCycle an entirely object storage solution? And that's interesting because you've kind of mentioned a lot of stuff about file systems, and then we think of cloud.
Yeah, it works with both. Such. Yeah, it works with both. So, people, I think sometimes people wrap their head around object storage a little funny, thinking that object storage is super unique. Object storage really is a separation of the frequently accessed data from the bulk data. And the frequently accessed data happens to be the metadata in almost all cases. So object storage has been around for a very long time. A media asset manager, the thing that I was talking about in one of the slides there, that is a very specialized piece of object storage. What they're doing is they're taking the clip, reading the header of that clip, looking at the camera, the aperture of the lens, the location possibly, the time of day, the name of the clip, anything else that could be in that header, and they're storing it in a database, and then they're taking the bulk data and leaving it in the archive. And what it allows, an editor to do is he can type in, I need clip 17, take 2, and it will find that for him wherever it is out on disk. So that's an object store. StoreCycle can work with either one of these worlds. It can store data in file. It can store data on object by going to Black Pearl. It can put data to the cloud. Right now, on the front side, we're doing POSIX file systems. There are some other things coming out there that we can do object and other pieces there. But so I don't think of it being a object storage system. I think of it being a data mover or a storage resource manager with a data mover attached to it.
Gotcha. Okay, great. Now, the reason we're not using the chat function for Q&A today is because that's a one-way session going out. If you look in the chat box, you'll see a link to that white paper that Matt mentioned. We had that dropped in there, so if you want to download that, it's a great read. And I think that is about it for the Q&A. So I want to thank everyone for joining us today. Matt, thank you for your
You bet.
time. Appreciate it. And we will look forward to the next time. Thanks, everybody.